Hello students. So today we are going to start the new chapter of C programming, which is pointers. So let us see where from the concept of pointer comes. So the first thing, some advanced features of functions. So as you have already studied about the basics of functions, and you have seen that functions are some block of a program which is intended to do a specific task. And in any part of the program, if we want to uh, do that particular specific task, so it can be any type of calculation of something, or it can be processing of some data like that. So in that case, we will call the by the name of the function, and at that uh, instant the function will be called and that specific task will be performed. So today we will see some advanced features of the function. So among them, the first thing is comes that is the function declaration and prototypes. The second thing is the calling function by value or by reference, and here the concept of pointers is required. And the last portion is the recursion. So today in our class we will study about the second thing, that is the calling function by value or reference, where the pointer we will discuss. So call by value and call by reference, what does it mean? So when we call a function in a particular portion of C programming, it is normally done uh, by this way. Like we have some variable name which is sum equals to cal sum within first bracket a comma b comma c, or in this way that if it is one variable equals to factor within bracket a. So in this way we have seen that we can call a particular function which is named as calsum, and in the next part of the C programming there we will write the what is the calsum function actually. And there we have seen that in the calsum function we will have some variables uh, that is like in our example we have given previously, that there we have used some variables like calsum within bracket x comma y comma z. So in x, y and z, basically we are passing the values of a, b and c from the calling function, whereas this a, b and c, they are called the actual variable which are basically declared in the calling function. And in the called function their corresponding variables are considered to be x, y and z, and within that variables, like a's value is being saved in x, b's value is being saved to y, and c's value is being saved to z. In that way basically the values are being passed to the called function. Okay, now what happens inside the function, the mathematical operations are done. Like in case of the cal sum, we are going to calculate the sum of the three numbers, and after the calculation we basically return the summation of the three numbers. So in return we have seen that we normally use a return statement in the function, and in the return statement we give a variable. Like if in the function we have written a instruction like s is equal to x plus y plus z, then we have to write that return within first bracket s. Then what will happen, the variable s's value will be returned to the calling function. Okay, and there we will get that value of s will be basically stored in that variable sum of the calling function. So in this way basically we can perform the mathematical operation inside the function and get the result of that in the calling function. Now there was a problem. What was the problem? We have already pointed out that using the return statement from a called function, we can return only a single value. Okay, so in that case, if some in some program, if we require to return more than one value from the called function to the calling function, then it is not possible using the return instruction. So how we can do that? So to do that, we have to go for the call by reference. So what does it mean by call by reference? So call by reference, to understand the concept of call by reference, we have to first know about a special feature of C programming, and that is the pointer. Okay. So now let us see what is pointer. So every variable is stored at a memory location, and every memory location has its address. So you see, when we store some variable in a memory location, okay, like in a particular program, if we have a variable I, suppose, okay, so what we actually do by declaring this like int I, when we write int I equals to 3, so what actually happens here? The compiler will first reserve a space to store an integer. Okay, so that space is basically the memory location, or you can call it address. Okay, so in the memory, a particular space is reserved for storing an integer, and a name is given to that space. Okay, so that name is I. Okay, associate the name I with that particular memory space. Then we store 3, that is the value at that particular location. Okay, so in this way, 3 things. So one is the location name, another one is the value at that location, and the initial and the basic thing is that we have to reserve a location. Okay, and in memory, every location has a particular number. Okay, so here we consider that when we initialize or when we declare the int I equals to 3, then this 6485, this particular memory location is reserved. Okay, now when this particular memory location is reserved for storing this variable, so here the variable's name is I and the value is 3. Now you see here the memory location which we have selected, like 6485, it is not a fixed memory location. If we run the program for next time, it may occur that this particular variable I is being stored at some other memory location. Okay, so this space is basically dynamic in nature. So every time when we run a program, this memory location can be changed. Okay, so here pointer is what? A pointer is a variable whose value is address of another variable. Okay, so that means here we are considering a memory location that is the 6485. If we have another variable, suppose p, and within p we are storing this value, that is that 6485. Okay, so then p will be called as a pointer. Okay, so pointer is what? Pointer is a particular variable which stored the address of another variable. Okay, now to denote or to write the pointer in the C programs, we have to know some syntax. And what are the syntax? So the syntax is something like this. To know the syntax of writing a pointer, we have to know about the 2 operators, that is the address of operator and the value at address operator. Okay, so what is the address of operator? Let us see. Over here we have a program. In this program, we have used that address of operator. What is this? You see in the first line, we have main, then int I equals to 3. Then we are printing how the printf slash n address of I, percentile u, comma, ampersand I. Okay. So what does it mean? Ampersand I. This ampersand is the address of operator. So when we write ampersand I, it is going to refer to the particular address where I is stored. Okay. And how we can print it? To print this, we are using the syntax percentile u. So why we are using this percentile u? Because normally we use the percentile d to print any integer, but percentile u is used to print unsigned integer. Okay, and as the address of I, that is address of any variable, this is always a positive integer, right? So there is no sign of getting any negative integer over there. So that is why while we are going to print the address of any variable, it is always a unsigned integer. Okay, so that is why we use the percentile u. Okay, and after that we are printing the value of I, that is percentile d we are using. And if we get the output will be something like this. If we consider that the I is stored at the memory location 6485. Okay, hence the expression ampersand I returns the address of the variable I. Okay, so now next thing is the other pointer operator in C is asterisk. Okay, this asterisk. So we call it as a value at address operator. So how it is used, let us see in the next program. So here you see we have similarly defined the variable I is equal to 3, and then printf address of I ampersand I, here we have written. So ampersand I means address of I. Next we are printing the value of I. So here we are writing like this, and then again we are going to print the value of I, and here we are writing in this way, that asterisk within first bracket ampersand I. So what does it mean? It means that ampersand I, this thing is basically the address of I. So if we consider the same situation that we have initialized, that is I is stored at memory location 6485, then ampersand I is basically giving the value 6485. And when we write asterisk 6485, that means at value at this memory location. Okay, so when we write asterisk ampersand I, it is basically referring to the value at that particular memory location. Okay, so that is why the value at that memory location is obviously 3. So that is why in the third line also we get print, that is the value of I is equal to 3. Okay, now over here, this particular thing, that is the 6485 memory location, which we get by using this command ampersand I, this we can store in some other variable. Okay, in the C instruction we can write this, that is j is equal to ampersand I. So over here j becomes a variable where the address of I is getting stored. So if we see this diagram, so what is happening over here? I is a particular variable which is stored at this memory location 6485, and we are taking another variable, that is j, where we are going to store this value, that is the 6485, that is this memory location we are going to store over here. So j becomes another variable. So as j is another variable, so j must need another space where it is going to be stored. So where it is going to be stored? It is going to be stored over here at this memory location 3276. So we are arbitrarily chosen this particular memory location. and it can be any memory location. Okay, so j is now a variable which is stored in this memory location, and it is storing the address which is this 6485. Okay, so j's value is now a address. Okay, but wait, we can't use j in program without declaring it. So as j is a variable which contains address of an integer I, it is declared in a program as int asterisk j. So what does it mean when we declare int asterisk j? If we just write int j, what does it mean? It means that j is an integer, simple integer. But when we write j asterisk means int asterisk j, that is the value at address j. So j is what? Now it is showing that j is a address. Okay, and it is a address which is actually storing some integer. Okay, so that is why int asterisk j is representing that j is a memory address and it is storing an integer, and this j can be stored in any other memory location. Okay, so this asterisk is basically called the value at address. Okay, now in this program we can see how to use that asterisk and the ampersand, that is the value at address and the address of these two operators. So here you see we have one initialize one declaration, that is int I equals to 3 and int asterisk j. So what does it mean? It means that I is an integer and its value is 3, and j is a pointer which is an integer pointer. Okay, we call them integer pointer. The pointer which is storing the value of some integer, we call them integer pointer. Similar to that, we can have float pointer, character pointer, all those things. And here the j equals to ampersand I. That means j is going to store the value of the j is going to store the address of I. Okay, now if you just print them, what kind of output you will get in the first line? That is when we are going to printf address of I equals to ampersand u, sorry, percentile u ampersand I. So this thing, what does it mean? It is going to give you the value of address of I. So if you consider the first example, it was 6485, something like that. So you will get that print in the first line. In the second line, we are going to again print j. So j is basically that address. J's value is basically that address, that is the 6400. In the second line also, you will get the 6485, all these things. So what kind of output we will get over here? That suppose address of j. Okay, address of j, we are writing what? Ampersand j. So what output it will give? What print it will give? It will give the address of j, which we have considered like something like 3276, I think. So if you see the, sorry, so that output you will get in that case, sorry, yes, 3276. So in this line, ampersand j, you will get the print, that is in the third line, you will get the value to be 3276, like that. So similarly, we can have, suppose if we consider this statement like value of I percentile d asterisk ampersand I. So ampersand I, that is the value at address, and asterisk means sorry, ampersand I is the address of I, which is 6000, in this case 6485, and value at this particular address is 3. So in this line, for this line, we'll get i's value. Okay, so this is how we can use the address of and value at address, these two operators. Now, the pointer declaration, I have already told you that the what type of pointer we are going to point, means what type of variable we are going to point using a pointer. Depending on that, we have to declare it, like the pointer to an integer. Okay, so when we are going to store the address of some integer, we have to declare it like int asterisk IP. So IP is basically the pointer name. Okay, we can also point towards a double variable, so double asterisk dp, like that, float asterisk fp, character asterisk ch. So all these things. So next thing is that, as we know, the pointers are variables, so this will also be stored in some memory location. Now this memory address can be stored in another variable. Okay, so pointers are also some variable. Okay, and as they are also a variable, so these variables can also be stored in some memory location. So like in this case, if I'm going to say that, if I say that j is a pointer to the integer I, so what is the value of j? Value of j is the 6485, and where it is stored? It is stored in some memory location 3276. So now what we can do, we can have another variable which will refer to this particular memory location. Okay, so in that case, we will say the variable k, if the variable k is storing this value, that is the 3276, this memory location. Okay, then we say that k is a pointer to a pointer. Okay, so this is also possible. Like previously, we have seen that pointer to integer, pointer to character, all those things. Similar to that, pointer to a pointer is also possible. Okay, so by the same manner, we can have this, that k is stored in some memory location 7234, and if we have some other variable like m, where we will store this particular value of 7234, then we can say m is a pointer to a pointer to a pointer, like that. So in that way, we can increase the degree, but actually in normal C programming, we do not require that much mm, pointer to a pointer to a pointer, like that, all those things. We can stop our using the concept of pointer by using a single pointer which is pointing towards any other type of variable, or at the max we can use the pointer to a pointer, right? So this is another thing. Now next is, here in this particular example, you can see the concept of pointer to a pointer. Like here, in the last line, we are writing like that, that is the k. Okay, so when the address of j, so j is a variable and address of j is basically k. So here you see we have written in this way, that int I equals to 3, value at address, that is the asterisk j. So asterisk j is a integer pointer, and asterisk asterisk k, so it means that k is a pointer to a pointer which is pointing towards the integer. So that is why asterisk asterisk k, like that. So, and how we are writing, that is j is equal to value address of I, and k is equal to address of j, in this way. And we can get also the printed the value of k, like that. So the address of k, we can have some other means when we are typing, that is the address of k ampersand percentile u ampersand k. So what does it mean in this particular line? It means that we are going to we are going to print the memory location of k. So that is also possible by using this ampersand k. Okay, so next thing, so now we are quite familiar with the concept of pointer, and now we can refer back to the discussion where from we started, that is the call by reference. So in case of the call by reference, now what we do, instead of passing the value of some variable from the calling function to the called function, we will pass the address of that particular variable. Now we have been familiarized with the concept of the address of a variable. Okay, so what we do, we will pass the address of a particular variable to the called function, and the called function will operate on that particular address. Means the call function will operate on the value which it finds on that particular address, and according to its uh, program's logic, it will process that particular value, and a new value will be generated. Okay, and that value will be stored in that particular memory location. So in that case, when in the from the main function or the calling function, we will, after execution of the function, from the means after execution of the called function, from the calling function we can have the changed value of those particular variables. So how it is happening, we can see it by using some example. Okay, so in this particular example, you see here we are intended to swap two variables value. Like we have taken a variable as a is equal to 10 and another variable b is equal to 20, and we are using the swap v function, where we are passing the value of a and b to the function, and then we are going to print the value of a and b. And what is the swap b function? You see swap b function here, we are initialized or declared the two integers, that is integer x and integer y. So when we write in this way, that implies that a's value is referred to x and b's value is copied to y. Okay, and then the function, in the function we have taken another variable, that is the int t, the third variable. So using the third variable, using this logic, we are swapping the value. We are storing the value of x in t, then we are assigning the value of y into x, and then we are getting the value of t again into y. So this way we can swap the value of x and y, and then we can print it like using printf, this command. So if you see the output of this particular program, you will get in this way, that x is equal to 20 and y is equal to 10, but a is equal to 10 and b is equal to 20. So here inside the function, the value has been swapped, but when it is going to return it, there occurs the problem. So in the calling function, the value of a and b remains unchanged. Okay, why here is a problem? Because here this particular function cannot return two variables value to the calling function. Here the two variables are the x and y, so x and y's value together cannot be sent back to the calling function. Okay, so that is why the value of a and b are not changed. It is local. Okay, the value of a and b are the locally initialized value that is remaining. So locally initialized means in this particular calling function, whatever value we have initialized to a and b, that remains unchanged, though in the called function the value has been properly swapped. So this is the problem if we are using the simple function. Now if we do it using the call by reference. Okay, so how it is working, let us see. So while we are doing the call by reference, we are initializing the same thing, that is a is equal to 10 and b is equal to 20. Then swap r, we have taken another function swap r, where we are passing what? We are passing value at address. No, we are passing the address of a, address of b. Okay, so we are going to pass the address of that particular variables. Okay, and here swap r, here we are basically initializing two pointers. Okay, and they are integer pointers. So asterisk x, so what does it mean? It is going to store a particular memory location. Which memory location? Memory location of a. Asterisk y, what it is going to store? It is going to store the memory location of b. After that, what operation we are doing? We are taking another variable t. So t is equal to asterisk x. X is what? X is a memory location. So asterisk x means value at address x. So t will do what? T will store the value at address X. Then what is we are doing? The value at address X is equal to value at address Y. So in the Y address, what value was stored? The Y address, the value which was stored, it was 20. So now 20 is stored at value at address at that particular address of X. So in the address of X, now 20 is stored. And then in the address of Y, now 10 is stored. So now the variables has been changed in the address itself. Okay, so that is why we have directly processed the address of those particular variables. Okay, so that is why when in the next step, when this particular line is being executed, that is printing A and B, so basically in the address of A and B, we have processed those variables. Okay, so that is why the values have effectively get swapped. Okay, so another this is another thing, that is the so this is how we have seen by using the call by reference, we have been able to return two variables value. Okay, same thing we can do in this particular program also. So here in this program we can show you that instead of returning only integer, we can be able to return any other type of variables using the value by reference concept, that is using the concept of the pointer. So what we are doing here in this particular program, you see int radius and float, area and pointer. So we have taken two type of variable. One is radius, which is an integer, and area and perimeter. So these are some float. Here the function is going to calculate the area and perimeter of a circle, and the user will give the radius of that particular circle. Okay, so this is done using the printf scanf command like this. And here we are calling the area peri, a function, and in that function what we are going to pass, we are going to pass the value of radius, and we are going to pass the address of these two parameters, that is the area and the perimeter. So these two variables address we are going to pass in this particular function. Okay, and then we will print them. Okay, area and perimeter we will print by using the calling function. Okay, and in case of what is the function now? So in the function, when we are writing the function here, area peri within first bracket, int r float asterisk a, that is you see here we have used both the type of concept, like int r. In int r, so r is taking directly the value of the radius. Okay, but here asterisk a, so float asterisk a. So what we are doing, we are passing the address of variable area to the variable a. Okay, similarly we are passing the address of perimeter to the variable p. So this a and p are basically pointer to some float. Okay, and after that we just do the operation like a is equal to pi r square, that is the area is equal to pi r square, we know that. So asterisk pointer a is equal to pi's value is 3.14 into r square, and asterisk p 2 pi r. So that is done. And when we give the as a sample run, we are giving the input, that input as 5. Okay, so radius is 5. So at that time, if you just manually calculate by using this formula, you will get at 78.5, and the perimeter to be 31.4. So it is effectively returning these two values, basically the area and the perimeter, to the calling function. Okay, actually here the concept of returning is not coming. Here we are directly processing the value at that particular memory location. Okay, while we are using this value at address a, we are not going to deal with the variable a area. We are going to deal with the value at address a. Okay, so this is how the pointer helps us to change the value as per our requirement, and it can be happening for any number of variables. Okay, using the concept of pointer, any number of variable can be processed in the called function. Okay, so that's all. I hope the concept of pointer is now quite clear to all of you. Thank you. Now we are ending the class.